Okay, let's come back to our chapter 12. So chapter 12, we're gonna talk about risk and uncertainty management. Okay, so up to now, when we talk about probability or risk, we are thinking it as something that we should simply accept it. Okay, like the example I gave in the previous class, we were talking about weather forecast. Okay, suppose you know tomorrow it has a 60% chance it will rain. What can you do? You can only take precaution on that. And suppose it rain, you take out an umbrella or something. You cannot change the probability, right? You cannot change whether it will rain tomorrow or change the probability of that. But in a more managerial setting, in a company setting, it's actually sometimes possible for a manager to take some action or make some decisions so that the risk can be reduced. Okay, for example, it's not true that the company have to invest on risky asset or risky action. Okay, and sometimes even different way of running the company can actually change the probability of some event from happening. Okay, so in this chapter, we're gonna talk about this kind of scenario. Okay, so we'll use this example as a main example in this chapter. So this is a Two Valleys company. It has different sources of uncertainty at this company. So there are two different sources. One could the cost could be a risk. The revenue could be a risk. The cost risk come from fixed cost and variable cost. The revenue come from open market demand and whether we won a specific contract with another company. Okay, and suppose the estimated value for a uncertain factor are given as follows. So we're choosing between two different locations. These are two different locations. One is this Callum Fall, and this is a Littleton. And there are so the fixed cost, variable cost, demand, and probability of winning a contract can be shown as follows. So, for example, the annual fixed cost, the most likely number is 7.5 million, and the highest possible number is 9 million. The lowest possible is 6 million, and so on. And the annual demand in unit in million is the demand is most likely to be 4 million. The highest possible number is 7 million, and the lowest possible number is 1 million. And because the annual demand doesn't depend on the location of the choice here, and also the probability of winning a contract doesn't depend on whether the location is in A place or B place. So these are as these numbers. Okay. So if you draw the cumulated, so this is basically the CDF for annual profit at the two sites, then you will actually find this. Okay, and we've learned this, right? So in this case, this is first order stochastic dominant. So this is preferred to the other. So Littleton is better than Colin Phillips. Okay, from the graph you can see that. Remember we talked about this? It's first degree, not first order. first degree stochastic dominance, FDSD. It's first degree, right? Or first order. First degree, yes, it's the same thing. It doesn't really matter. Okay. Okay. So and you can so and this is basically like a sensitivity analysis. So for example, the action here is do nothing. If you do nothing, then obviously there's no increase in expected profit, and there's an 8%. Wait a minute. I do this like 2 weeks ago, so I'm a little bit confused here. But I think the other numbers were given in the textbook. But based on the information in the textbook, you can draw this graph, this table. So if you do nothing, then you increase your expected payoff by 0, but you have an 8% chance of a loss. And the lowest possible profit is 2.8 million. Something like that, okay. But this is not really that important. This is used to construct something called the tornado diagram. Okay. Oh, okay, I remember now. So in the textbook, it gives you a function of how to calculate the profit, right? I forgot to put it here. I remember now. Sorry, can someone in the textbook want to write down the equation? Okay, so as the textbook said, profit equals demand times price minus variable cost plus probability of the contract being get the contract times contract times the contract sales times this is really long. The discounted price minus the variable cost and then minus the fixed cost. Okay. This is in your textbook page 301, okay? So I just need to draw this so that I can remember the line. But so okay, so basically what it shows here is using this formula in your page 301 and construct different result of different management actions. So if you do nothing, if you actually make the contract signed, if the contract is actually signed, this has become 1, right? This means the contract is actually signed. And the fixed cost at the lowest, to make sure that the fixed cost is at the lowest, or to make sure the highest possible demand is, there's the highest possible demand, or to make sure the variable cost is at the lowest. So these are events that could potentially increase the expected payoff, right? And here we can choose to do the action that is most profitable. So it's the fixed cost, to make sure the fixed cost is at the lowest because the increase in expected profit is at the highest. Okay, that's how you basically decide if you want to do something, what would you do? That's the idea. Okay? Yes.
How did you manage to complete the table?
Using these equation that's in your page 301.
Yes.
So for example, the fixed cost at the lowest, okay, you assume everything else at its normal level or the most likely level. For example, the price is actually given in the textbook. The price is given in the textbook is some number, okay, and the variable cost, the most common number is 3. Per unit is 3. So price minus that. Actually, this is wrong. This shouldn't be a million here. So because per unit cannot be in million. Okay. So you put 3 here, and probability of contract, you put the most likely probability, that's 0.6. And the discounted price is given in the textbook. Variable cost is the same variable cost. And the contract sale is also given in the textbook. And the fixed cost, you use the lowest possible fixed cost. Then you can calculate the demand, you also use the most likely demand. That's 4. Then you can calculate the thing. For that action, what is the increased expected payoff? Okay? And this is similar to a thing called tornado diagram. We actually went through this before, but it was a little unclear, I think. So to do this tornado diagram, we do something similar to what I just said. You assume, for example, if you need to do this one for demand, you assume fixed cost, variable cost, and probability of contract are at their most likely value. That's here. You assume they're in their most likely value, and you calculated this and this to the two end using the highest possible demand and the lowest possible demand. So you assume everything else at its most likely number, and then you change the number that you care about, here is demand, to its highest number and the lowest number. Then you will see when the demand goes from the lowest to the highest, what is the possible range of different profit. Understand? Okay, that's just one line. Okay, you need to do this 4 times to get fixed cost, variable cost, and the probability of contract. Okay? And this is for Littleton, but you can also do this for Falls. Okay, and so suppose you are choosing a location in the Littleton, then, changing the fixed cost can actually give you a big chance of success. A really big success. But it could also lead you to something that's really bad. Okay, although it's still positive. And changing the contract, for example, changing the probability of the contract, whether you won the contract or not, doesn't really change the game here. Because either way, your profit is gonna around 2 million to 3 million. That doesn't change much. What that means is you shouldn't care too much about this domain. Okay, you should not put your effort to make the contract happen or not. Just let it go. Okay, just make sure it happens with some probability. You're fine with it. But with this one, if your company choose the location in Collinville, it's totally different story now. Now everything depends heavily on the demand. Okay, then in this case, you should make sure that the demand is at its highest level. Maybe you should need to do some marketing or something else. Okay, so and this part is what we call brainstorming. Basically, you need to look at this graph or this one and think as a group, think about what is the next step that we should do. Or after we know what we should do, for example, we know we need to make sure that the demand are at its highest level. What should we do? Okay, so I give one example, like to increase demand, maybe you need to do more marketing. Or to increase demand, maybe you need to make sure that maybe the product is more likable, something like that. So, and the textbook provides some ideas or advice on how to do brainstorming. So it's just some common notion, like do not criticize ideas, encourage participants to put forward any idea that they can think of, try to generate large quantity of idea, encourage people to combine or modify ideas that have already been put forward. Excuse me. So actually this is similar to what I hope I get from you guys. Okay, so if I ask you question, I won't criticize your question or your idea, but I encourage you to put forward your idea, okay? And so that I can generate a lot of different ideas, so I understand what you guys are thinking and what I should focus on, okay? So key questions are like this: how can we reduce fixed costs? How can we increase open market demand? How can we reduce variable costs? Or how can we increase the chance of contract being signed? This is changing the 4 different domain that we were talking about, right? So after you have these key questions, then you can talk about how to change them using the brainstorm. And this is for the original for the Littleton company. So maybe after your risk management, the distribution will further go to the right hand side. Then you will have a less risky scenario. Okay. Yeah, this chapter is actually quite short. I'm gonna go to the next one if nobody have questions. Any questions? No? Okay. Okay. Now I want to talk about the experiment results from last time. So last time there was this questions. The first one is, what is the probability of a flood sometime in the next year in North America in which 1,000 or more people drown? Actually, half of the people were asked this question. The other half were asked this question. The other question is, what is the probability of a major earthquake in the Pacific causing a flood sometime in next year in North America in which 1,000 or more people drown? So obviously, Q1 probability should be greater than Q2, right? Because here it gives a very specific event, major earthquake in Pacific. Here, the earthquake can be the flood can be caused by something else, like the hurricane or something. So in general, the research in the past are showing that, however, people are doing this because it's easier to imagine that an earthquake causing a flood and thus causing the people to drown. Okay, but you guys were actually doing pretty well, I guess. So so actually the first group, the median is 37%, and the second group is only 9%. Okay, so it's different from the research before, but you guys get the idea. Okay. The second one is the following. So, which of the following two options do you prefer? So the option A is you pick one ball out of a bag with 10 green and 10 red balls. You receive $10 if you pick a green ball and 0 otherwise. So just 50-50 chance of getting $10. B is out of a bag with 18 green, 10 red. You pick a ball out of a bag 7 times, each time returning into the bag before picking again. You receive $10 if you pick a green ball each of 7 times. That means, I hope the English here is clear. That means all 7 times you need to pick the green ball. Okay, then you can get the $10. And so in fact, this is 18 out of 20. So that's actually 0.9%, 0.9, and to the power of 7. .9 to the power of 7. So that's around 48%. So in fact, A should be preferred to B because A has a 50% of winning. In the second question, so actually also half of the people were asked this question, the other half were asked this question. The option A is the same, 50-50 chance of winning. The second one is out of the bag with 18 green and 2 red. You pick a ball out of a bag 7 times, each time returning to the bag before picking again. You receive $10 if you pick at least 1 red ball and 0 otherwise. So only need to be at least 1. So it means 1 minus always picking the green ball. That means at least 1. Okay, so always picking the green ball is the same probability as before, so it's actually 48%, around 48%. So it's around 52%. So this case, actually B is preferred to A. Okay, but because of anchoring, here the anchoring is that you were thinking that 90% is really high, and by picking a 90% chance in a row is still a high probability. Okay, and here is the opposite. You think that the red ball only has a 10% chance. Although I only need to pick it once, it seems unlikely that I will actually draw it. Okay, so just like the usual research show, you guys so half of the people in the first type of question, more people choose option B. More people choose this one. And more people in the second type of question choose option A. More people choose this one. Okay? I hope after this you should be able to understand the anchoring more because you actually went through it twice already. Got it? Okay. And this one is represent versus likelihood. So people actually have very different understanding of representative and likelihood, although they should be similar measurement. Okay. So this question was given like this. So you know for certain that Steve is either a farmer or salesperson, airline pilot, or physician. Okay. So by saying X, I mean one of these profession. Okay. So Steve is very shy and withdrawn, invariably helpful, but with little interest in people or in the world of reality. A meek and tidy soul, and he has a need for order and structure and a passion for details. And then half of the people will ask, what is the probability in percent that Steve is a X equals to farmer or salesperson and so on. And the other half of the people was asked out on a 0 to 100 scale, to what extent does the description of Steve resemble the description of a X? Okay, and interestingly, so if you ask about the representative, people think farmer, airline pilot, and physician are sort of equally likely, sort of close to each other. But in terms of probability, farmer is much, much lower. Okay, and that's actually because when people are thinking about the resembleness of a, for example, a profession, we were picking the thing that we think that's more plausible, not the thing that's less likely to be plausible. For example, here it says that this person is with little interest in people, but I would actually think physician would have quite a large interest in people. But maybe because other things like shy and withdrawn, or maybe invariably helpful makes you think that he's a physician. Yes.
The thing that I understand is like this is very subjective, because you can be like not that much interested in people, but you can also like so much I do not close, and so that you're going to be a salesperson. To me, it's really dependent on. It's really subjective.
Yeah. This is just a declaration or a showcase that show you guys how people would really differ in just sort of assessment about description or probability. Okay, so in a perfect world, what we should see here is that these two distributions should really close to each other. That's what I'm saying. That's all. Yeah. Okay. And the last one is actually quite interesting. I thought you guys would get this correct, but actually not. So a town has 2 hospitals. About 45 babies are born each day in the larger hospital, and about 15 babies each day in the smaller. Okay, so 3 times more babies are born in the larger hospital. Only 15 are born in the smaller one. Over the course of 1 year, which hospital is more likely to have had more days on which more than 60% of babies born were boys? The correct answer is the small hospital. Option B, the smaller hospital. But a lot of you choose about the same, and some people even choose the big hospital. So, care to explain to me why you choose A or C? Yes.
I choose C because I thought that the size didn't matter because the proportion were about to be the same, even this is the norm.
Okay, maybe the size here didn't signal you that it matters actually a lot. Okay, for example, if the smaller hospital only born 2 kids a day, you still think that doesn't matter?
No, it matters.
Okay, but it matters for the same reason. For 15 and 45, because the sample size is triple. So it's still, we're just saying it's likely or not. Okay, so it's still much more likely that the smaller sample would have an unbiased result. This is like you throw a dice many times. In long run, it will converge to 1/6 chance of getting a 1, for example. But if you only have like 6 samples, then it's really hard to actually see 1, 2, 4, 5, 6 all happen to be ones. Okay? So that's why the smaller hospital has a more likely to have it. So definitely not the large hospital. But for those who choose about the same, I guess depends on how you define about the same. So yeah, it's not entirely wrong, I guess. Yeah. But actually it's much more likely that it's in the small hospital. I don't have the exact number here, but yeah. Okay? That's about that's about the experiment from last time. So we're gonna go through the chapter 13. Decisions involve groups of individuals. Okay, so the motivation of this chapter is that sometimes as a group you need to make a prediction. Either that's a result, a binary result. Either as a group you need to make a prediction of whether some event will happen, or you actually is a probability, or it's a number for what is the expected sell next year, something like that. As a group, you need to make a decision. Okay, so suppose, for example, now I'm gonna this company is choosing between two actions. So either it's gonna buy the high volume processor or the low volume processor. And the in the PM's view, the product manager's view, the average sell in those cases are if you buy the high volume processor, and if the average sell is high, then the revenue is 1, and if the utility is 1, and if the average sales level is low, value is 0. It's a more risky choice. But if you buy the low value processor, then even if the demand is high, the utility is low. But if the sales level is actually low, then we're good. We actually have a moderate utility. And here is the probability of that event from happening. This is the subjective probability, what the PMs think. Okay, this is for one person. Okay. Now we add the second person, the accountant. The accountant also think that when the high value in the high volume processor case, the high and low utility are the same. But the low volume processor utility is different. And also the expected utility are different. However, from the expected utility theorem, we found that both the PM and the accountant want to choose the low volume processor. Right? Okay. But if we use a simple mathematical aggregation, we might not get this idea. So here, these two people will both suggest that we should buy the low volume processor. So probably the manager will decide to buy the low volume one. However, if we use the average method, we average these numbers. So 1 and 1 average is 1, 0 and 0 average is 0, 0.1 and 0.52 together is 0.62, average is 0.61. Okay, you do the average calculation. And then you calculate the expected utility. Now you see that buying the high volume processor actually have a higher expected utility. Okay, so which processor should we actually buy? That's a big issue, right? The two-way give me different idea. Okay, so this is just one example. But aggregating judgment or like this kind of decision in general has a lot of problems. So, okay, and most study actually suggest that if you take an equal weighting, or basically this is an equal weighting, or because we simply do a simple average between the two, so it's an equal weight, 50-50 weight. Okay. Sometimes you want to, maybe this is a more PM thing, so PM utility should matter more, then you should give him the higher weight. Okay. But in general, research has shown that equal weighting of individual judgment work as well as more complex method. And often, you don't need that many people. You only need like 5 or 6 people to make a good judgment of average estimate. Okay. Okay. But aggregating probability judgment has its own problem. This is because the domain that we are working on is different. Okay. So here, we have an example. We are estimating a geological problem and a equipment problem. A's estimate is 20% geological problem, 60% equipment problem. B's estimate is 40% geological problem, 90% equipment problem. We assume independent, so we can get this. 0.2 times 0.6 is 0.12, 0.4 times 0.9 is 0.36, right? But we can also use the average method we just said. So average between these two is 30%. Average between these two is 75%. But if you time these two together, it becomes 22% to 22.5%. But the average between these two numbers is 24%. And these are not equal to each other. So what is the correct way? That's the issue here. Okay. And aggregating preference ordering has an even bigger problem. Okay. This one you can say that 24% and 22.5% is not that far away from each other. We are sort of fine. Okay. But preference ordering is the other. So for example, if Edward, Fletcher, and Green are voting 3 candidates. Candidate A, candidate B, and candidate C. This is an election. Only 3 voters. Okay, assuming that there's only 3 voters. Edward prefer A to B to C. Fletcher prefer B to C to A. Green prefers C to A to B. Okay. So how depends on the voting rule. For example, if we vote between, we do A versus B, winner versus C rule. Okay. If A versus B, Edward gonna vote for A. Fletcher gonna vote for B. Green gonna vote for A. So A win. A win. So A versus C. Here, A still win, C now win, C now win, so C win. Right? So supposedly it should be C is better than A and better than B. But if you do the rule differently, now you directly compare C and B. C and B, I like B more. This person also like B more. This person likes C more. So actually B will win. So B is preferred to C. This is what we call a violation of a transitive, right? Transitivity. Do people understand what I'm saying? Do people understand what is violated here? If not, please raise your hand or tell me, okay? Don't be silent. I don't understand. So, C prefer to A to B. This is okay.
Yeah, just so how do we choose which one is better? Because it changes every time with a different method.
Yeah. That's a different issue. I'm talking about whether you understand what I just said. Yeah. Okay, so there could be a violation of transitive. In general, this is actually, I'm just using an example to show that, but in general, like you said, that's a big problem. Actually, this problem is bigger than you thought. There's a very famous theorem. It's proven by a economist, Kenneth Arrow, who I think died a few years ago. He's like died in 90 or 100 something. Okay. Arrow has this is his most famous theorem called impossibility theorem. The theorem states that, so here I give 4 conditions. Okay. So this sort of election method or choosing, aggregating preference method, this method must produce a transitive group preference order. And if every member prefer an option, so must the group. If everybody think A is better than B, then this method should tell me that A is better than B. Reasonable, right? The third rule is that group choice between 2 options does not depend on preference for any other option. If you're choosing between option A and option B, it shouldn't matter if the option C show up or not. Because your preference between A and B should only depend on A and B. Okay. And I don't want a dictator. Do people understand what is dictator? I don't want someone to decide for everybody. Okay. And turns out you can prove mathematically. So this is a fact. Okay. This cannot happen. So does not exist such a method in the world. Okay. What that means is you should know that, for example, in Taiwan and the US and in France or in many, many different countries, although we all call democratic society, we use very different election rule, right? But there's not actually a better election rule or the best election rule, because there is no such a rule that even can satisfy these 4 conditions. 4 simple conditions. Okay. Another way of structuring or state this possibility theorem is only use the first 3 conditions. And that means what that states that if I want to find a method that satisfies the first 3 conditions, the only method that works is dictatorship. Is you assign someone as the dictator and decide for everybody. Okay? That means in the election, the best policy is to find someone, everybody decides, someone will decide who the president is and that person will decide it. That's the only thing that can work if you need to satisfy the first 3 conditions. And if you add the option that you cannot have a dictator, then there does not exist such a rule. Okay, and I know that in this class people might not be that familiar with mathematical proof, but what mathematical proof means is that you cannot find a counter argument in the future, even if technology advances. Okay, it's impossible. Even in the future, that's just not possible to find such a rule. That's for sure. Okay, so that's very bad result, I guess. And aggregating values and utility has another issue that actually I think Ben actually mentioned this quite a lot when we talk about value function and utility function. So because when people say that, for example, this is choosing between 3 different vacation locations. So person A say that Rio give him the utility of 100. San Francisco give him the utility of 40. Toronto give him the utility of 0. And person B think that San Francisco give him the highest utility, and Rio gives him the utility 50. Toronto also give him 0. And if you simply use the average method, Rio will be chosen because he has a highest average utility. However, my 100 or A's 100 might be different from B's 100. Okay, I say that San Francisco give me 100 utility. This is in B's term. For member A or decision maker A, the same 100 for real might actually means only 40 for person B. Okay, so sometimes, but in general, the problem is you don't know how to rescale it. But if you do know how to rescale it, after you rescale it, then for person A become 40 and 16 here, then the final choice will become San Francisco. Okay, so it can reverse. That means because you use different weight, basically. Okay. So far, we are talking about mathematical aggregation, and I've shown a lot of the example, basically to show you that there's no perfect way, because all kinds of different aggregation mathematically have its own problem. Okay. And if you really need to do mathematical aggregation, for example, in election, we still need to use mathematical counting numbers of vote, right? So basically people compromise. People use a rule that satisfies some other condition. We cannot find a rule that satisfies all the conditions we already gave you, right? But we can find some other condition that this rule might satisfy. So maybe so maybe US use a very weird system where for the presidential election, each state has its own voting, and the result will decide all the what's the English term for that? But basically each state will represent numbers of votes. We all goes to the winner, right? But that might be because in the United States, their country's name is called United States, right? So they were originally united different states into one country. So each state has its own power or speech. So so that maybe that's more like closer to their the constitution spirits that they choose to do so. And in Taiwan, for example, we only started the presidential election when I was like 8 years old or something, and it's not that long, right? And we don't have really that many history about this, so we use a very simple rule that whoever has the majority votes will win. And I don't know about the French history, for example, that well, but I do know that French has several rounds of voting, right? Something like that. Yeah, but I don't know the origin of that, but it might be because some historical reason or something. So people compromise to choose different rules. So that's how we settle the situation. Okay. And there are other methods to do this. For example, one way is to use the behavior aggregate. So general, this is called behavior aggregation. Okay, and behavior aggregation, except for the one method called prediction market that we'll go through in the next few pages. Other methods are basically group discussion. Okay. Other methods, so the so-called behavior aggregation, means you gather some people together or gather some people online and make a group discussion with some specific way. Or maybe it's not even specific way, just people, what they call unstructured group process. Just you don't really have a structural method of discussion. Just like I said, now the class, please discuss about whatever topic. and you'll go discuss it. Okay, and this way, especially in a company setting where there's some hierarchy between like the boss, the manager, and you, something like that, they tend to have a phenomena called groupthink. Basically, the tendency of the group who have been working together for some time to make poor decisions. And why they make poor decisions? Because sort of social pressures to conform or to avoid conflict lead to suppression or contradiction of opinion. Basically, you want to conform with the group. Okay, so you might give very poor judgment. Okay, so either you might have a high group cohesive, or there may be some lack of methodological procedure for searching for praising opinion, or there's a very clear hierarchy in the company, so your boss tell you so. So there's directive leaderships. Different conditions can all lead to this kind of groupthink phenomenon. And the symptoms are like, for example, you may be more optimism than you think that you should actually be. So because you, as a group, you all think the future is gonna be so bright, your company is gonna be so so good. For example, have you guys still heard of the company Blockbuster? No? That's a company where they rent people videotape and DVD in the 90s or in the 80s. Okay, and they were at some point when Netflix just came out, there was one time the Blockbuster had a chance to acquire Netflix with a relatively low price. But they say no because they think Netflix is gonna not be a good idea, and keep renting people DVD and videotape is a better idea than streaming video online. Or back then, Netflix back then was actually sending you the DVD, and you can return the DVD by mailing it back. Okay, I don't know if you even heard of that. And yeah, so I guess in the Blockbuster setting, they were thinking that their company is gonna be really good in the future, but nobody can really come up with a unique idea that's saying that it's not the case because whatever reason. Okay, so other thing maybe like, or as a group, a good thing is that you may be very strong as a group because you are all tied to each other, you're supportive to each other, right? But at the same time, you might, if you have an enemy, you might stereotype your enemy or rival, think they are evil, weak, or stupid. But that might not be a good view, because your rival, you should judge your rival as they are, not more stupid than they actually are, not more evil than they actually are. Or I guess shared illusion of unanimity. That means everybody think that the group as a whole are agree on one thing. There's no disagreement, but in reality there's many disagreement. Like for example, I do know that you guys during the class may have more questions than you actually raise, but what can I do? Some consequence, I think you can read the text, that's not that important, but basically it's just saying that what's the consequence of these kind of for example, poor information search, just in general, that if you read the textbook, you have some more detailed description. So those are unstructured method. So and may cause serious groupthink. So that's why people started to invent new methods to prevent groupthink or to make a better judgment about to aggregate group decision making. Okay, so the first method is called the Delphi Method. Okay, so in the Delphi Method, it's designed to obtain the estimate from the group of people without the biasing effect of face-to-face discussion. So the key word here is face-to-face. And to ensure the airing of a diverse view. So I want to have diverse view, and I don't want you to have a face-to-face communication discussion, because if you're face-to-face, you might be, get the pressure, social pressure from the other. Okay. So what they actually do is they will form something called the panel group. So the whole panel group will be formed by many panelists. And these panelists might actually be all anonymous. And to make them anonymous, they can even be remote. Okay, maybe this company is a multi-country, multi-million company and has different location, different country. So, from San Francisco, from Taiwan, from Germany, or different countries, we can all submit the opinion anonymously. Okay, I will talk about the role play later. And the result of this polling, for example, everybody said that their estimation of the event A from happening, the probability of the next success of the company, for example. Okay, and then I don't feedback. I don't give feedback to each of them, the whole distribution. I give them a statistics of group opinion. For example, the mean, the median, or the mode, something like that. And then I will get the polling again. I ask them to give their new estimation after they see the statistic again. So maybe, for example, your original estimate is that next year there's a 50% chance the company will grow. But you see that the average estimation from all other people, or including you, the average estimation is 10%. You might rethink, right? You might rethink about it. Okay? So, the above process is repeated until the consensus emerge, or no further change of opinion are evident. Just the number converge, basically. Everybody's numbers converge. And the final prediction that give by the group are the median of the group. Okay? So this is like, okay, obviously we're not anonymous here, but imagine that you guys are all in some different places rather than here, and you're all anonymous. The process is like, if I ask you to estimate the final average grade of this class, okay, you will first give me a number, and then I will aggregate everybody's number and give everybody back a average and a mean. So suppose everybody give me, suppose you say 60, someone say 80, someone say 70, the average is 70. I will tell you the average is 70, the median is maybe 75, something like that. After you see the number, you will give back to me another set of number. And I will give you the statistic again, and come back again, and back and forth, until the number basically converge. Or there's a consensus, everybody's number are close to each other. And then, if this process ended, then we use the group median as the prediction. Okay? And there are some added feature that can be used. The textbook call it role playing. Basically, in the first stage, the first round of our group discussion, there are several ways to improve the quality. One way is this: I will pair you guys to another person. So maybe you two is a pair, you two is a pair, and in each pair, one person would be doing exactly what you did before. Just make an estimation. Okay? And the second person I will finish this at least. The second person will make in one way they call it devil's advocate. Just you make a exact counter argument. Okay. Suppose you say 70, I will say 30. Okay. If we are a pair, then you say 70, I will say 30. And I will counter argument every single piece of your argument of why it should be 70. Okay? So to make you think, why maybe it's not 70. And another way is similar, but you don't give exactly the counter argument, but you try to give an alternative argument. Maybe you say it's not 70, but maybe 60 is more reasonable, and I give the reason why I think 60 is more reasonable. Okay, I'm playing a role as, maybe I actually agree with you, but I'm playing a role that's different from what I actually do. Yes?
If the person you pair with knows that it's a method, it's going to work because...
It still makes you think. I mean, for example, in the law firm, the lawyers, they go to the court, right? They make a lot of the defend and offend in the court. What they usually do is they don't directly go to the court and practice the law. They usually do a mock court in their firm by their other lawyer in the firm. So some lawyer play the judge and some lawyer play the opponent lawyer. But that still is a common method people use. But people do know that they're playing the other role play. Yeah. Yeah. So I will not be able to finish this today. So I guess I will continue next time. This is chapter 13, right? Yeah, this is chapter 13. So don't do chapter 13, but do chapter 10, 11. Sorry, I should not use red. It should be like this. Do chapter 3, 10, 11, and 12. These three exercises. Not that many. Okay. And I will finish chapter 13 next time and we'll run a very fun experiment. At least I think it's fun. Okay, we'll see you next time.